Okay, so this is unabashedly a trick question. Okay, a loop of wire with a radius of 0.78 meters is in the plane of this page. It's rotated so it starts out in the plane of the page, right? And then it's rotated so that it forms a 23-degree angle with the page, right? Okay, so the change in flux is going to be that the let's see, there's the magnetic field is into the page, right? Okay, and the reason that the flux is changing in this case is that we are changing this loop, and when it's rotated, it's as seen from above is going to look like that. It's going to be kind of oval looking, right? So there will be fewer flux lines going through it. Okay. What's really changing here is the angle of this thing. So if we draw a little line here, here's the loop maybe at flat with the page, right? I'm looking at this from the side. Let's look at it this way, right? And then if we tip it up 23 degrees, the loop is going to be like that, right? 23 degrees, only it'll be like the same length, right? Okay, but we've changed it like that, and so remember that area vectors are perpendicular to the loop, right? So this area vector is actually like that, right? But our magnetic field is just this way, right? Here's our magnetic field into the page. Okay, and so what's going to happen is that we start out with a flux of BA cosine of 0 degrees, right? That's 0 degrees, right? And then we end up with a flux of BA cosine of, well, it turns out that this angle and this angle are congruent, right? So the angle between the area and the magnetic field, okay, is 23 degrees. Okay? So ultimately, that's what's going to happen here, is that we have BA cos theta of like full flux minus that flux, right? And that's our change, is that, right? So when we set this thing up, the magnetic field is 3.72 Teslas, right? The area is pi. Let's see, it's a radius of 0.78, so it's pi times 0.78 meters squared, right? Okay, and then obviously the EMF is this divided by T, right? Okay, and then what I'm going to do here is I'm just going to factor out this cos, right? The cos of 0 is 1. That's the cos of 0, right? That's supposed to be a 0, right? And then I'm going to go minus cos of 23. Like that, and then I'm going to divide that by the time it took. How much time? 0.015 seconds. Okay, so let's figure this out. Okay, 3.72 times pi times 0.78 squared times parentheses 1 minus cosine of 23, right parenthesis, whoops, that was a fail. Just hit the tangent button. Okay, let's see. Let's go delete, delete, delete. Okay, I think I'm ready. I can do a right thing. And then I'm going to divide by 0.015. Hopefully that won't. 37.68, is that right? So I get 37.68 volts of EMF, right? Okay. So that's my EMF, that's the answer here. And then the question is, why is it clockwise? Well, we have flux into the page, right? Okay? And we are losing it. So we're losing into the page, right? Well, if you lose flux into the page, what you do is you replace it. And the way to make flux into the page is make the current go clockwise. Remember, you wrap your fingers this way. If you wrap your fingers clockwise, your thumb is into the page and you're replacing it, right? So replace is clockwise. Okay, so it's going to go clockwise. Alrighty, how about that one? Not the best video in the world, but it's a video.